Hi, so I am going to go ahead and film module 1.1 today, and this is going more in depth into ratios. I have already filmed an entire unit on ratios, and so this is now unit 2, module 1.1, and it is understand ratios. So our learning target, I can show a ratio relationship between two quantities using different representations and describe the relationship using correct mathematical language. The vocabulary that we are going to be learning: a ratio, part to part ratio, and part to whole ratio. We have already discussed what a ratio is in the previous video. So again, a ratio is nothing but a comparison of two quantities using division. So let's go more in depth into what a part to part and a part to whole ratio is. So I'm just going to give you a quick example of part to part. Let's say, how many students do I have in this classroom who have blue eyes compared to students who have brown eyes? So now that does not include all the students in the classroom. It just includes one portion to another portion of students in the classroom. So blue eyes to brown eyes, and that is an example of part to part ratio. And then we have a part to whole ratio. So if I say how many brown-eyed students to the total number of students in this class, remember the total amount is going to have brown eyes, blue eyes, hazel eyes, green eyes, etc. So that is why that is part. If I say brown eyes is the part of the whole, which is the total number of students. So that's the difference between part to part and a part to whole ratio. So let's start with looking at a table that I have created over here. And this is talking about, the table shows the ingredients needed to make the total amount of lemonade over here. So we're going to discuss about what the total amount of lemonade is in a minute. And how does the number of cups of lemon juice compare to the total number of cups of lemonade? Okay, so let's look at this. A ratio of the number of cups of lemon juice to the total number of cups of lemonade. So how do I find the total number of cups over here in this recipe? So I'm going to take all of these and I'm going to add it up. So I have 2 plus 1, which is 3, plus 7. So my total over here, total number of ingredients, the number of cups is going to be 2 plus 1 plus 7, which gives me 10 total. All right. So when I'm looking at the comparison, there's one way that I can use this comparison is in the form of a bar diagram. And so if I look at a bar diagram, I know that if I have a total of 10, okay, there are 8 more cups of lemonade than there are cups of lemon juice. And this is an additive comparison because 2 plus 8 gives me a total of 10, right? So this is an additive comparison, okay? This is an additive comparison. And now what I'm going to do is I am going to show the comparison by using a bar diagram. All right. So if I have 2 cups of lemon juice, okay, so this is my lemon juice, and I have 2 cups of lemon juice. All right, that is 2 cups of lemon juice. So this whole thing is 2 cups. And then I have 8 more cups of lemonade than lemon juice, right? So if I have lemonade, this is going to be a total of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is 10 total cups. 10 total cups of lemonade. Okay? And so then I'm looking at how many more cups of lemonade than lemon juice do I have? So if I look at this portion, this is 8 cups more. Okay? So that is why this is called an additive comparison. Now, a part-to-part ratio and a part to whole. So let's talk about what the difference is. So we know that a ratio is a comparison between two quantities in which for every A unit of one quantity, there are B units of another quantity. The phrases for every and for each are used to define and describe ratios. Okay, so let's talk about the relationship between the quantities of ingredients in the recipes. And these are examples of ratios. So again, to make one batch of lemonade, you need 2 cups of lemon juice, right? So if I'm looking at what I've just drawn out over here, think of it this way. For 2 cups, I have this 1 and 1. That's 2 cups. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get 10 total amount, and this is for one batch. Okay, so this is for one batch of lemonade. Now what if I need to make 2 batches of lemonade? Okay, so I'm just going to erase this really quick so that you can see what I'm doing. All right, so this is for one batch. Okay, so for 2, what will I do? And I'm just going to put this over here so you can see. This is for one batch of lemonade. All right, so for 2, you can have the same ratio. So this is my lemon juice to my lemonade. Okay, so this is 2 and okay, let's try to make this a little bit shorter. But let me fit my 10 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so all right, just I'm running out of space, and that is why I'm doing it this way. Here we go, and this is my 2 that was represented earlier. All right, so now we're going to see what's going to happen when I have 2 batches. All right, so instead of ones that I had over here, what am I going to do? I'm going to make each of these over here 2. This is 2 and 2. So I'm just going to because it is an equivalent ratio, that's how this is going up. So now let's look at this. What do we have here now? So we have 4 cups now of lemon juice up here. Okay, and then I have 2 times 10 over here, which would be 20 cups total of lemonade. All right, and this whole thing is for now 2 batches because we've got to double the amount. So this is 2 batches. All right, so we are doubling the quantities to make 2 batches. What about 3 batches of lemonade? So if I have 3 batches of lemonade, again the same thing. If I am making this bar diagram, this is for 3 now. This is lemon juice. This is my lemonade. Okay, so same thing. So this is my 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now, as you can see, instead, this is for 3 batches. What am I going to do? I'm going to put 3 here. 3 in each of these because these are all ratios which are equivalent. All right, and now if I look at this, what do I have? I have 6 cups over here of lemon juice to 30 cups here of lemonade. And then this one is for how much? This is for my 3 batches. And so this is how you can see that these ratios are equivalent, and no matter how many batches are made, there are always 2 cups of lemon juice for every 10 cups of lemonade in this recipe. And this confirms the same relationship between cups of lemon juice and the cups of lemonade is being maintained. All right. So part to whole, again, a part to whole ratio compares one part of a group to the whole group. So this is a part to whole recipe. So because I am comparing the lemon juice to the total amount over here. So that is why this is a part to whole recipe. The ratio 2 to 10 is a part to whole ratio because it is comparing the number of cups of lemon juice, which is the part, to the total number of cups of lemonade, which is the whole. So this is a part to whole ratio. Okay? And I can obviously, and we've talked about the 3 different ways to write a ratio. So I can write it as 2 to 10. I can write it as 2 over 10. Or I can write it as 2 to 10. So these are my 3 ways that I can write a ratio. So this is my part and this is my whole. So this is a part to whole ratio. Okay, so let's quickly talk about a part to part ratio. So part to part ratio. So I'm just going to erase this really quick. So now we can talk about a part to part ratio. All right, so let's say a part to part ratio, it compares one part of a group to another part of the same group. And the ratio 2 to 7 is a part to part ratio. The 2 to 7 is a part to part ratio because it compares the number of cups of lemon juice, which is one part, to the number of cups of water, which is another part needed to make the lemonade. Okay, so in this case, if I just have, this is part to part, 1, 2, and 1, 2, 3, 4, 5, 6, 7. So let's look at this one. The part that we have for lemonade, it's going to be this one and this one for the lemon juice. Okay, so this is 2 parts. And this is my lemon juice over here. All right. And then I have the 7 cups that I need of water. So this is 2 parts, which is 2 cups that I'm talking about. Okay, so these are 2 cups that I'm talking about over here. And then I have 1, 2, 3, 4, 5, 6, 7. So this much over here is the other part, which is my 7 cups of water. 7 cups of water. Okay, so this is your, what is this? This is 2 cups of lemon juice to 7 cups of water. So this is my part to part ratio. This is my part to part ratio. And then if I'm supposed to write this out as a ratio, I would write it out as 2 to 7. So remember, this is also a part and this is also a part. So this is called a part to part ratio. And I can write it like this. I can write it like this. So that is the difference between part to part and part to whole. Okay, so let's quickly talk about an example, and I'm going to take you to my whiteboard for this one. And if I take you here, and there we go. All right, so let's look at the question. Pedro mixed 2 sample containers of blue paint with 3 sample containers of yellow paint to create his favorite shade of green paint. Pedro realized he did not have enough paint, so he added 2 more sample containers of each color. Will the new mixture result in the same shade of green? And justify your response. Okay, so to create his favorite shade, what does he have? He has a part to part. Okay, so as you can see in this one, we have how many parts of the blue? We have 2 parts of blue. Okay, so I'm just going to do it here. So this is my blue, which I should have done with the blue color, but that's fine. Okay, so that is my blue, and this is 1 plus 1, so this is my total is 2 parts, right? And then I have, because see, 2, this is 1 and 1, so which is 2, and this is 1, 2, 3, which is going to be 3 parts of yellow. So 1, 2, and 3. Okay, so this is 3 parts of yellow. Okay, because look, 1, 2, 3. So what is my ratio over here? It is 2, 2, 3. That is what my ratio should be. Okay, but now look what it's saying. He's adding this new mixture, and so what he does is he just adds on 2 of blue, because it's saying did not have enough paint, so he added 2 more sample containers. So he added 2 more of the blue, so 1 plus 1, and the total amount is how much here now? This is going to be 4, and he added on 2 more of the yellow. So how much total do we have in the yellow? So we have 3 plus 2, which is 5. Okay, so if I had to draw out the bar diagram, this is what I'm doing. He has now 4, 1, 2, 3, 4. This much is the blue. Okay, and then he has 1, 2, 3, 4, 5, and this much is the yellow, because this is 1, 2, 3, 4. This much is the blue, and then 1, 2, 3, 4, 5. This is my yellow. So the ratio is 4 to 5. Ratio is 4 to 5. Okay, now the amount of blue paint in the new mixture is twice that of Pedro's favorite shade. And to maintain the same ratio, the amount of yellow paint should also be twice that of his favorite shade. But if I do 3 times 2, I get 6. But here he is getting 5. So therefore, it is not equivalent. So he should have done what? He should have added another paint. So he should have doubled it. Because look, we have talked about equivalent ratios, and I had told you that you can use cross products to see if 2 ratios are equivalent. So if I have 2 to 3, is that equal to 4 to 5? Okay, so let's look at this. So we do cross products. What is 2 times 5? 2 times 5 gives me 10. Is that equal to 3 times 4, which is 12? No, 10 and 12 are not equivalent. So it did not turn out to be an equivalent ratio. Okay, so what he should have done is, if he had 2 to 3 and he got 4 by doubling, so look, doubling, that means times 2. He should have also doubled the 3 and got a 6. And so this would have been the correct answer, but that's not what he did. Okay? All right. Let's look at this one really quick. All right, a recipe for rice is calling for, let's see, 6 cups of water and 3 cups of uncooked rice. Okay, so 6 cups of water for 3 cups of uncooked rice. And let me just use a different color. All right, so 3 cups of water. Okay, 3 cups of water for 6 cups of uncooked rice. So this is water. No, sorry, 3 cups of rice. 3 cups of rice for 6 cups of water. Okay, so I'm just writing it like this. And that is my recipe. So she reasons that, let's see, Trinity only has 2 cups of uncooked rice. Okay, she only has 2 cups of uncooked rice. And so she's thinking that because she has 2 cups of uncooked rice, she reasons that because she subtracted 1 cup of rice, she needs to use a total of 6 minus 1. So what she's going to do, 6 minus 1, and she's getting 5 cups of water. 5 cups of water. All right. And is her reasoning correct? All right. Is that reasoning correct? No, it is incorrect if you look at this, because they are definitely not equivalent ratios. Okay. For every 3 cups of rice, there are 6 cups of water. To cook 2 cups of rice, Trinity needs to use a total of 4 cups of water, because the number of cups of water is twice the number of cups of rice. Okay. So if I look at this also, look, 2 times 6 is 12. And 3 times 5 is 15. So it is definitely not equivalent. Okay, definitely not equivalent. All right, let's look at this one. And here is a problem. It talks about part to whole ratios. So a florist is arranging flowers in vases to sell to her customers. She has 2 sizes of vases available, small and large. She wants the large vase to have the same ratio of flowers as the small vase. If the large vase has a total of 36 flowers, how many are tulips? All right, so we can use a bar diagram to represent the ratio of tulips to total flowers for the same vase. Okay, so if I look at this once again, I'm going to look at how many tulips do I have. Okay, here we go. So let's look at how many tulips do I have, right? So I have 4 tulips, all right, in the small vase, and it's talking about the large vase has a total of 36, but then first I need to look at, okay, my ratio overall, 6 plus 2, 8 plus 4, my total is how much? It is 12 when I add all of these up. Okay, so if I am using a bar diagram to represent this, okay, so this is my tulips, and that is, okay, 4 of them. 1, 2, 3, 4. Okay, so this is a total of 4. Okay, as you can see over here, we have 4 tulips over here. And then I have total amount of flowers is how much? Is going to be, my total amount of flowers is 12. Okay. So then I'm going to just make another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so now I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total amount that I have is 12. Okay, this is my ratio right now that I have. Okay, so 4 to 12. Now, using the same ratio to find the number of tulips in the large vase, okay, so I know that when I look at this, each section in the diagram, because it says the large vase has how much? 36 flowers, okay, so I'm going to keep the same ratio of 4 to 12. Each section must represent at the what? How much? What is, you know, if I have 36 divided by 12, what am I getting? I'm getting 3, right? So each of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So, and then I have my 1, 2, 3, 4. Okay, so these are my tulips, and this is my total. Okay, and so this becomes, each is going to become 3. Okay, to maintain that same ratio. And then here we go. 3, 3, 3, 3. All of them are 3. All right, so then this gives me, as you can see, 36 flowers total. To maintain that ratio, and it's asking how many tulips are there. So what is 3 times 4? That gives me, I will have 12 tulips when I have the part to the whole in this case. Okay, now I can also quickly show this in the form of an equivalent ratio. So I could have written this as what? 4 over 12 is equal to what over 36? Okay, how many tulips over 36? I wonder if you can see that. So 4 out of 12, because 4 out of 12 is how many tulips if I have a total of 36 flowers? So 12 times 3 gives me 36. Whatever I do to the denominator, I do the same thing to the numerator. So that gives me 4 times 3, and that is 12. So that would be 12 tulips. Okay, and that's how I find the part to whole. Okay, so let's do another quick example of part to part ratios. A bakery sells fresh baked muffins sold in small or large boxes. The manager of the bakery wants to maintain the same ratio of each type of muffin in the large box as in the small box. If the large box contains 9 chocolate muffins, how many blueberry muffins are in the large box? Okay, so let's look at this one. And it's asking, first we're going to use a bar diagram to represent the ratio of blueberry muffins to chocolate muffins for the small box. Okay, so we can see that the blueberry to chocolate in the small box, so we have to first look at that ratio. I'm going to write it as a bar diagram, but I'll also show it to you. So we're looking at this and we're looking at this. Okay, so I can also write it like this, 2 to 3, and that is my ratio. But if I was doing a bar diagram in the small box, okay, in the small box, all right, so I would have 2 to 3. So this is 1, 2, 1, 2, and 3. Let me try to remove this much. Hold on. There we go. 1, 2, 1, 2, 3. Okay, so this is 1, 1, 1, 1, 1. So this much here. Okay, this is my blueberry. This is my blueberry. And then this is my chocolate. Okay, and then as you can see, my ratio is what? We have a ratio of blueberry muffins to chocolate muffins, which is 2 to 3. For every 2 blueberry muffins, there are 3 chocolate muffins. And then you use the same ratio to find the number of blueberry muffins in the large box. Okay, so this is the small box. And then in the large box, it says I have a total of how many chocolate muffins? I have 9. Okay, so if I was doing this, 3 times what gives me 9? 3 times 3. Whatever I do to the denominator, I do the same thing to the numerator, and I do times 3. So then my answer should be 6. So if I was making a bar diagram in this case, I would just do the large box, and then again I would have my 5 parts. 1, 2, 5 parts. Okay, and then each of that would be 3. 1, 2, 1, 2, 3. Okay, and so you can see that this much is blueberry, which is 6, and this is my chocolate, which is 9. Okay, so therefore this ratio is being maintained because there are at 3 times as many chocolate muffins, 9 in the large box, as they are in the small box, which is in the small box you have 3. So there are 6 blueberry muffins in the large box. Okay, so basically this is what how you use bar diagrams in order to find ratios. You can do part to whole and part to part. So once again, please remember the difference between the two. Okay, and part to part is part of one, let's say, recipe ingredient to another part. If you are, for example, baking a cake, how much flour to how much sugar do I need? The cake definitely has way more ingredients than just a flour and sugar, but then that is part to part. And part to whole is part of something like, for example, in this classroom, how many students wear glasses is the part to the total number of students, and that would be whole. So basically that is what this first module is about, and we discuss a lot about the vocabulary, which is part to part and part to whole. Please make sure that you also watch the video on ratios that has been created before this to understand and comprehend ratios properly. All right, have a great day.